and so forth. Okay, so the first important rule we have that we've already been talking about is the sum or difference rule, which says that if I'm adding two functions up, like let's say I had x squared plus sine x. What's the derivative of x squared plus sine x? 2x. Okay, you just do them. You do each one, right? You do the derivative of x squared, you do the derivative of sine x, you just add them together. So in rule form, it would look like this. The derivative of f plus or minus g is what? F prime plus or minus g prime. Just very simply that. You just do the derivative of the first thing plus or minus the derivative of the second thing. So when we're adding or subtracting two functions, it's just very basic. So, and we've already done that without really thinking of it as a rule. Another rule we've had that we've used a lot is what if you have a constant times a function? Like what if you have 3 sine x? What do you do with that 3? It just hangs out there, right? The k just would stay there and you multiply it times f prime of x, the derivative. So the constant would just stay there, and we would just multiply it together. All right, so now, here's the new rule. What happens, we have two of them today actually, what happens if you have a function times another function? Not a constant, but another function. So for example, what if we had x squared, what if we had y equals x squared times sine x? Well, if things were really going to be nice and easy for us, it would equal what? It would be 2x cosine x. That's what it would be. We would do the derivative of the first thing, 2x, times the derivative of the second thing, cosine. That would be it. But unfortunately, it's not. We can go into a lot of reasons why it's not and so forth. What we're going to do is in a minute have Brittany do this on the calculator. But we could refer back to this, actually, to see this constant one, to see why it can't be with that. Because constant is a function itself, right? It's just not variable. It's always constant. Well, if we did that to this, we'd have to do the derivative of the constant times the derivative of this, right? What's the derivative of a constant? 0. So if we applied that same principle up here, the derivative of a constant would be 0 times that. This would always be 0. And we know that's not true. The k just hangs out there. So then it'd be like, well, could the f just hang out? Well, no. Because then how do you tell which one's supposed to be first? It just doesn't work that way. Okay? So, Brittany, go ahead and put into your calculator the derivative of x squared times sine x. And hit enter. Okay, so now let's look at the answer that gave. See if you notice what it did. I like it. Didn't it kind of like take turns? Yeah. Isn't that kind of what happened? Would that be a way to describe it? It said, you know, let's leave the x squared alone and do the derivative of that one, which would be cosine. And then let's flip that. Now let's do the derivative of the x squared, which is 2x, and then leave the sine one. It's exactly what it did. And since there's a plus sign there, it doesn't matter which order we do it. Just to make things simple, though, I'm going to do it in the reverse of what they did. Now, the calculator wrote it this way because it likes to have the high power first. I'm going to do it this, pretend I had this term first. So what I'm going to do for the rules, I'm going to say it this way. So we're going to take turns. So we're going to do the derivative of the first one times the second one left alone. So it'd be f prime of x times g of x plus f of x times g prime of x. So I just take turns with a plus sign in between. Now, if you think about that, that would actually work for the constant now. Think about this constant example. We could take turns with the example of k. We would never do that. If we have a constant out front, we're just going to say it hangs out there. But think about what would happen. Let's do a take turns thing. Derivative of the constant is what? 0. Leave the f of x alone. Plus constant left alone times the derivative of f would be f prime. Well, 0 times f of x is just 0, and you end up with k times f prime. So it works even in that setting. Okay? So that's how we're going to do it. Now, I'm going to write it a little differently because as we go through this, writing all the f of x, all those x's in there, there's just no need for all those x's in there. We know x is the input variable because we have this x down here. Right? The derivative down here means with respect to x, our input variable. So I don't really need all those x's. And instead of using f and g for some reason over the years, this has kind of been the convention to do this. I'm going to let u be one function of x, and I'm going to let v be the other. So I'm just going to write u times v. This is in the book this way. It's in most books this way, so we'll write it this way. So notice we still have the x down there. X is still our input. So this is like two functions, u of x and v of x. Okay, so it's u, like u is the x squared, for example, up here. So this would be the u, and that would be the v. Okay, right there. So it's u prime v plus uv prime. And it just rolls off the tongue. Easier. U prime v plus uv prime. But basically, we just take terms. And there's a plus sign in it. That's called the product rule. That's called the product rule. So when you're multiplying two functions, that's how you do the derivative. All right. Now, let's do a couple of examples for that. So we can see the one we did with x squared and so forth. So let's try this one. Y equals e to the 3x times cosine of 4x minus 1. So what we have is and of course, where the difficulty comes in as we go through the week is recognizing all the different variations. And am I using the product rule here? Is this a different rule we're learning? Or whatever? Putting it all together. So this is a product rule because I've got u times v. Right? I've got one function of x times another function of x. So y prime. So this is what the gateway test will look like. You'll have y equals something, and you'll write y prime. So derivative of the first is we have to kick out a 3, right? Kick out a 3. We're going to learn more about that kicking out stuff tomorrow. Tomorrow's focus will be stuff on the inside. What happens when we have this stuff on the inside? Okay, and then what do we do with the cosine? Leave it alone. And we multiply them, right? Those are multiplied together. Plus e to the 3x left alone. And we're going to kick out a 4, and it's negative sign. And we're going to leave the inside alone. Now, here's where people get in all kinds of trouble. Here's why not everybody gets 8 out of 10. Right here. Partly it's don't know the rules, but a lot of 6 out of 10s and 7 out of 10s are because of things like what I'm about to do right now. So I'll have people say, okay, now e to the 3x, I leave that alone, and now cosine, oh, that's negative sine 4x minus 1, and then they'll kick out a 4. Now, what's wrong with that? It's multiplication. That looks like a subtraction. And even if you put a little, and sometimes there'll be a little dot there, you know, I don't even like that, okay? You better get parentheses in there. And actually, I think we should rearrange. Now, I'm not real big on rearranging, just to rearrange, but some rearranging we need to do. I mean, part of what we'll be going through over the next week is you getting used to, you know, me saying, I'd like it to look like this, okay, and so forth. I want you to put these things together. This you should simplify, but this is probably not necessary to simplify, that kind of stuff. So we'll be going through and talking through that. And I'll pick here on the first one. You know, if you're going to get 30 out of 30, you're going to earn it. You know, it's got to look good. They got to really be done well. You know, if you're on the 7th one, you know, in mid-January, I mean, it might not be as picky. You know, so. But yeah, I just want to get ready to get it over with. I don't know. So First of all, that would have parentheses, but now you got this times this times this. I think you ought to bring the 4 and the negative around in front. So I think this answer ought to be 3e to the 3x cosine 4x minus 1 minus 4e to the 3x sine 4x minus 1. Okay? So it's okay to write it this way at first, as you write it down, but just keep track of those things and know if you need parentheses, and then look at it and say, now what can I put together? That's where the algebra stuff comes in. Okay, that's where the algebra stuff comes in. All right, so that's y prime on that one. Right? So some of these get kind of nasty looking. All right, now let's look in your book. If you would turn to page 167. Yeah, right.
What happens when you have 3 things that you multiply? Same thing, just another time?
Right, and I don't know, I'm not sure if they'll be getting in the homework, but that's exactly what you do. If you have 3 things multiplied, you would take the first 2 and treat those as one thing. You with me? So if you had u times v times w, and you were supposed to do the derivative, I would treat that as 2 things. So you would do the derivative of the first, I'll just do this, times the second left alone, plus the first left alone, I'm running out of space, aren't I? Times the derivative of the second. Now, what are you going to have to do when you do that? You'll have to do a product rule again right here, right? So you'll have a product. So inside these parentheses will be a whole da-da-da plus da-da-da, and then the w, and then plus, and then this would be just u times v and then that. So yes, and so we'll get into some of those situations for sure. Yes. Okay.
Will there be any like that on the gateway test?
Could be. On the gateway test, there's 10 questions. I usually describe it as kind of 3, what I would call easy, 4 kind of in the middle, 3 fairly hard. So if you're going to get 8 out of 10, you got to be able to get at least one of the hard, what I might call hard one. Now, what's hard mean? Well, I don't want to focus on that a lot, but everybody always asks, what's a hard one? Is this hard? Is this a medium one? I don't know. It depends. Sometimes a hard one can be because it has some algebra in it that's kind of nasty. You have to simplify. Sometimes it can be because it's a derivative rule we don't run into very much, and you might forget it. Or that kind of thing. So, yeah. There could be something like that. That would be the hard. Yeah. All right. So now on page 167, I want you to look at 49, 50, and 51. Now, they tell you in the directions that f of 1 is 2, and they tell you that g of x, what do they tell you? This is on page 167, number 49, 50, and 51. This is similar to problems you're going to have in your homework. Okay, so here they give us a function g that is a product. It's x cubed, which is a function we know, times this unknown function f of x. So it's 2 different functions of x cubed and f of x. It's a product. They tell us f of 1 is 2, and they also give us the graph of f prime. Right? That graph down at the bottom there is the graph of f prime. And now they're going to ask us some questions. So this is where we take what we've just learned about products and we apply it to chart and things we should already know about from chapter 2. So in 49, they ask for what? They want to know g prime of 1, and they say estimate. And so that means there might be somehow, somewhere there's going to be an estimation, okay? Approximation. So we'll see when we get to that. Now, you'll hear me say this many times over and over here as we go through the week. Before I can find g prime of 1, I need g prime of x. Okay? And hopefully by the end of the week, when I say before we can find g prime of 1, we need, and you'll say g prime of x. Right? Because we need somewhere to plug the 1. We need to be able to plug the 1 in for the x. Okay? So before we can find g prime of 1, we need g prime of x. And then we'll just plug a 1 in for the x. Now, for some reason, this has been a difficulty for us ever since our very first quiz, which was all about function notation. We had some scores that were quite lousy with function notation, and I've been able to tell it because as we went through the year, every time that we run into needing some function notation, we struggle at times. And this is all this is. If we know g prime of x is something, then g prime of 1 is just a 1 plugged in everywhere there's an x. So here's g of x. So tell me what g prime of x would be. 3x to the second. No. Times just f of x, right? It's a derivative of the first, x cubed, derivative of x cubed, times this one left alone, plus x cubed left alone, f prime of x. So now this is not like what will be on the game. Like I said, as we go through the week, we will still be doing other problems that don't relate just to the gateway test, but will be things that will come up at later times, and things that we do need to know, and it will help us understand these concepts for midterm and those things as well. So it's just not all about the gateway. So anyway, that's the product rule right there. So now we want g prime of 1. We just simply go in here, and everywhere there's an x, we put a 1. Right? And so 3 times 1 squared is 3. What's f of 1? They told us in the directions that's 2. 1 cubed is 1. What's f prime of 1? No. You sure? Didn't they give us the f prime graph? Oh, you guys. Seriously, you know, were you taking the derivative of this? You guys have said 0. This is what I mean by function notation. F prime of 1 can't be the derivative of f of 1. What's f of 1? No, yeah, but at any time, what's f of 1? A number, right? Like ln3. F of 1 is always a number. So that would mean f prime of 1 would always have to be, right, if we thought about that. I mean, I'm sorry, I don't mean to make fun of you guys for saying 0, but it's a very important point. We've got to make sure we understand. That means every time I ask for f prime of 3, it would be 0, because f of 3 is a number, and so f prime of a number, you know. No, what is f prime of 1? F prime of 1 is a 1 plugged into the f prime function, right? Now, what is the f prime function? Do we have it up here? No. But we have a graph of the f prime function, right? So f prime of 1 is a 1 plugged into the f prime graph, and what is it? 4. 4. All right. So we get a 4 there. That's closely related to what I was saying here. See, because what I often have people say, you might have wondered, why was I making a big deal about this when I say before we can do g prime of 1, we need g prime of x? Why was I making such a big deal about that? Because I do see people do that. They say, well, I need g prime of 1. Oh, well, I'll just find g of 1 and then do the derivative. But you see the problem there? You do g of 1, you get a number, and then you do the derivative of that, it'll always be 0 all the time. So that's no good. All right. So we do g prime of x, we plug in a 1, and what do we get? 10. There we go. So that's what 49 wanted to know. So there really wasn't much estimating other than we had to read off the graph. But it looked like it was exactly 4. Okay, let's look at 50. What's 50 say? All right. Is g increasing at x equals 2? Now that sounds like stuff from chapter 2. What does that really mean? Is g increasing? What they're asking is g prime of 2 positive. That's what they're asking. So how can we find that? We've got g prime of x, so we simply take and plug a 2 in everywhere the x is. That will be g prime of 2. So 3 times 2 squared times f of 2 plus 2 cubed times f prime of 2. Right? So g prime of 2 is just a 2 plugged in to g prime of x. All right. So 3 times 4 is 12. What's f of 2? There's a problem. They told us f of 1, and all they gave us was the f prime graph. So let's hold off on that for a second. 2 cubed is 8. What's f prime of 2? That would be off the f graph, or the f prime graph at 2, it appears to be 1. So we got 12 times something plus 8. Now we don't really care what that is, we just care if it's positive, right? That's what we're doing. So what is f of 2? Well, let's see. This sounds like a speed limit law. I know on the f graph, at 1 I get 2, right, from this. And what can you, now I want to know what's the f graph doing at 2. Well, I can look at the f prime graph, and what's going on with the f prime graph from 1 to 2? It's positive. It's going down, but it's positive. So what's that tell me this point is at 2? If I go up, if I go over 1, I got to go up something, right? So it's going to be, so this is going to clearly be, so f of 2 is clearly going to be a positive number. So I'm going to have 12 times a positive plus 8. So that's definitely going to be positive, right? So therefore, so justify your answer. So since g prime of 2 by this is positive, therefore g has to be increasing, okay? So we can answer that question using our product rule. Okay, it's all based off that g prime that we did using the product rule. Okay, finally, 51. Estimate g double prime of 1. G double prime of 1. What do we have to do to get g double prime? We have to do another derivative. We have to do the derivative of that. So, 2 terms. The addition rule tells me that I do each one separately, right? So how do I do the derivative of this? I do the product rule again. Okay, it's like a double product rule problem, right? So, let's write it. 6x to the first times f of x alone plus 3x squared, not plus, times f prime of x. So that's that one taken care of. Plus now this one, 3x squared, f prime left alone, x cubed left alone, and the derivative of f prime would be f double prime. That's the second derivative. That's one of the things you get into that makes these a little tougher is you get into product rule and you have multiple product rules or whatever, especially when you get into second derivatives, they can really get messy. Those two could combine. They are definitely like terms, right? I have an x squared f prime plus an x squared f prime. That'd be 6 x squared f prime. It's not really necessary here because now all we're doing is plugging in a 1. But yes, you could do that. You could do that. So now I'm just going to put a 1 everywhere I see the x. I'll do this a little quicker. So this would be 6. What's f of 1? That was 2. And that'd be 3 times 1 is 3. F prime of 1 was, f prime of 1 was 4. And this would be the same. That'd be 3 times 4. And then 1 cubed is 1. And then what's f double prime of 1? How would we find that? Wouldn't that be the slope of that graph? That graph is f prime, so f double prime would be the slope. So we do a quick little tangent line there. At 1, it looks like if you go down 1, or excuse me, over 1, it goes down about 1.5 or so. That's what we thought in the other class. 1 or 2 maybe. Down 2. Maybe that'd make it easier. Let's make it 2. So about negative 2. Looks like you go over 1 and be down about 2. So we're definitely estimating there. Okay? The rest of them were pretty straightforward. So 12 plus 12 plus 12 is 36 minus 2. This would be about 34. The G double prime 1 is about 34. But again, we're using the product rule. But then this idea of function notation is very important about plugging in a value. And sometimes we just don't have 2 functions. Sometimes it's a graph. Sometimes it's a table. Right? We could have done the same thing, and I think they do in one of your homework questions. We could have done the same thing, but then they just had a table with some f values, some f prime values, some g values, whatever. And we could have plugged them in from the table. So table, graph, equation, everything.
So we had a problem like this, and we just give a range to the solution.
Usually a test like this where you estimate, or a question like this where you estimate in a multiple choice, and so the range of choices you have, one will clearly be better than the others. If you do an estimate on a free response question, then yeah, there's probably a range. Yeah. All right. So, one more rule to add up here then, and that is, obviously, if there's a product rule, there must be a quotient rule. And so if we have a function divided by another function, now, you could make any quotient into a product. You could just bring the top up as a negative power, but then you run into messy functions raised to a negative power that you really probably don't want to deal with. So it's most of the time better to just leave it as a quotient and do it as a quotient. But it's possible that unless the directions specifically tell you otherwise, which they do here in the beginning section, but later on when we get to the gateway test, you can do it either way, whichever one makes more sense to you. But this looks like, I'm just, instead of going just for time's sake, because I want to give you some time to work here, I'm just going to show you what it would equal. So the reason I had you write the product rule in this order is because the quotient rule is the same order, but the order matters because there's a subtraction in it. So the quotient rule says this: you do the derivative of the top, you leave the bottom alone, minus, and then you reverse it. The top's left alone, you do the derivative of the bottom. So again, you take terms. Instead of first thing and second thing, it's top thing and bottom thing. All over the bottom thing squared. So that's your final answer there. Okay? Now, there's another version. I don't think you'll probably use it, but I like to show people just, I don't know why. This is a version I learned in high school. So sometimes if I'm working and helping you on a problem, of course, you might hear me whisper to myself, I know, you'll know what I'm doing. High over ho. Okay, ho is down low, high is up high. Remember that. But this is how my teacher taught us this, and this is how we remember it. So, and then rearranged it a little bit. Instead of u prime v, we did the other way around, v u prime. So we said, okay, take the bottom, left alone, which is the same thing as that, the v, times the derivative of the top. But the way we wrote the derivative of the top was with a lowercase d, and we wrote it like that. So ho d high, minus, and then it's the top left alone, high, times the derivative of the bottom. So that's what I think too. It's more fun, but it's more complicated to remember. So it's ho d high minus high d ho over the bottom. Well, but he wrote it ho squared. So ho d high minus high d ho over ho ho. So if you want to remember it that way, I used to teach it that way, and then I showed the UV prime, and everybody liked that better, so I kind of did it. But there it is anyway, just. All right, maybe you can fit it into your calculus carol somewhere.
Yeah, no. Oh, cute. We have
Ho, yeah. All right, so that's, yeah, I think you would see it. Some places you see them do high over low, but I thought, because Christmas is coming up, I like ho-ho's a little better. But so low d high minus high d low over low low, but anyway, okay? All right. Couple more things. In this section, then, is the derivative of tangent. I'm just going to leave that for you to look up. Derivative of tangent. But now, why did we save derivative of tangent till now? Well, how can you write tangent? Sine over cosine. So it would be a quotient rule. You can just write tangent as sine over cosine, do a quotient rule, and then that's a derivative of tangent. Then it simplifies into what you find in your book. But and same with 1 over secant squared, you can do a quotient rule, or excuse me, secant's 1 over cosine, cosecant's 1 over sine, and cotangent is cosine over sine. So you could do a quotient rule with all of them to get it. Or you can memorize what they are. Now I would suggest by the time we get to next week, we will memorize. Okay? All right. So now, the problems I want you to be able to do. In your homework, and I want to do a couple of them together with you here. So, everybody's got the assignment sheet, right? And you're supposed to do 9 through 41 odd. Now, 9 through 41 odd is just do derivatives. Well, with one little addition, which I'm going to explain to you when we do a couple together here. And then 42 through 48 is like what we did on 49, 50, 51. You got a graph, you got a table, you're going to be doing some stuff with that. Okay, and then 79 is a problem that relates to kind of a story problem kind of thing that relates to what we've been talking about here. Okay, kind of a max-min kind of question. All right, it kind of relates to chapter 2. So what I want to do first is number 9. Okay, your first problem. I want to work that one with you. I want to explain what they mean by the directions. Now, this is the only time this little section here, 9 through 14 and then 15 through 20, where you'll have to do this. They want you to work it out 2 different ways. Okay? So on your homework, I would like for you to, just a couple of problems. It's 9, 11, 13, and then 15, 17, and 19, where I want you to work it 2 ways. Now, what do we mean by that? Well, when you're given a y equation, and you need to do the derivative, many times the first thing you have to do is simplify before you can do the derivative. I mean, for example, I can't count how many times in the last week that somebody's asked me, well, how do you do the derivative of 1 over x? I say, well, you don't do the derivative of 1 over x. You write it x to the negative 1. And then almost every time they say, oh, yeah, okay, then that's easy. Bring the negative 1 down. There you go. So how you write the equation makes a big difference in how easy or hard the derivative is. Same with roots. If you have a root, you want to write it as a power, then you do your rule. So the same thing is true with products and quotients. So number 9 says this. Y equals x times x to the negative 1. Now, you might look at that and say, well, that's a product. Right? And it is. It's 2 functions multiplied together. So let's do the product rule on that. And you read the directions, it says work this 2 ways. First using the product rule, second multiplying it out before you differentiate. Differentiate means to do the derivative. So let's do the product rule. So derivative of the first would be 1 times would it be a negative 1? Yes, you do. I don't know what I'm thinking. Sorry. Okay, let's say that again. The derivative first is 1. Leave that alone. Just testing you. Plus x times. Okay. So let's simplify this a little bit. This would be 1x to the negative 1. Just leave that. What would this be? What do you do with those powers there when you're multiplying? Add those powers together. So what would this be? Negative 1. What do you get if you add those together? That's 1 over x minus, isn't it 0?
0.
It's 0. Thank you, Raf. Now, that's the first way you're supposed to do it. The second way you're supposed to do it is to multiply this out first, or simplify it. Well, we could have added the powers together right away. Which is what? That's x to the 0, which is 1, which of course, or we could have done x times 1 over x. X times 1 over x is just 1, but that's just y. That's the y. What's the derivative of 1? 0. Now, which of those, if you had your choice, would you do? I would think most people do the second one. In other words, the point there is, oftentimes, if you can simplify it first, do that, and then do your derivative, because then you might not even need the product. Now, the one we did, x squared times sine x, we had no choice. We had to do the product, because you couldn't do anything with x squared times sine x. Okay? So that's number 9. So 11, 13 are very much like that. So do it once with the product rule. Do it again with simplifying it first, and show that you get the same thing no matter what. Okay, now let's do number 15. 15 says y equals x squared over x cubed. So first, let's do it by the quotient rule. Because it is. I mean, it's a quotient. It's function of x divided by another function of x. So derivative of the top, 2x, leave the x cubed alone. Minus x squared left alone times 3x squared. All over x to the 6th, right? X cubed squared. X cubed times x cubed is x to the 6th. So what do we get up top? We get 2x to the 4th minus 3x to the 4th over x to the 6th, which would be well, can I just subtract those or like terms? Isn't that negative x to the 4th over x to the 6th, which is negative 1 over x squared, right? So using a quotient rule, it's that. Now, I think it would have been much simpler in the beginning to just simplify this first. What's x squared over x cubed? 1 over x. Well, we just talked about that. How you do the derivative of 1 over x. You first write it x to the negative first. Then you do your power rule. So y prime would be negative 1 x to the, which is negative 1 over x squared, which is the same thing. So again, you would have been better off simplifying it first. But so I just want you just a handful of times here to go through that process of doing it as a product or a quotient rule, but then saying, hey, I could have just simplified this and then done the derivative, and you better get the same thing. But most of the time, you know, there's not a lot of simplifying you can do first. But you're always on the lookout for it. You're always on the lookout for, well, let's see, how can I write this function? And is it a quotient rule? Is it a product rule? What is it? Okay? That's what you're working on. So go ahead and work on the rest of your homework there for the rest of the time. And then tomorrow we'll get into the next rule. So every day for several days here we'll be adding some things to this. And then we'll have a lot of practice time by the time we get to the weekend and Monday. Okay?